Yo, yo, hi. Hello, yo, what's up? All right, we're back to it. I'm gonna be working on a programming language. Cast today, one more time. Today is the 7th of July. Making my own programming language. All right. So what exactly do I want to work on today? Was the thing that I was doing off stream. Guest. So what was I doing? I have added the thing where I can use, yeah, there you go. I can use the prelude now. So I have this thing. Here's my standard library, and I have the prelude module, which just so like where I'm trying to make these things be available. And I did that, but not exactly correct. So I will fix that first, and then we are going to move to the next thing. So here's the thing. What does it mean to use everything from a thing, right? So we use everything from the module. What is a module though, right? A module is nothing special. Hello, Nerdcell. A module is nothing special. It's like a structure, right? So what if this structure was not actually known at compile time, right? What should happen? You know what I mean? What should happen if this wouldn't be known at compile time? Well, in this case, we just we can basically refer to the fields of a struct directly, right? And in fact, there is a feature now that I've tried doing that. There is a feature like that in the Jai programming language. I'm not sure though. Is there like using on structs, unions, and enums? Let's see, maybe this one? Hello? My internet is bad today or what? Opening a new tab. Why couldn't it open it in? Oh, okay. It was just really slow. Okay, there we go. So Jai allows using keyword on structs, unions, and enums, importing all the members into that particular scope. So basically, you have a vector 3, which is a struct with x, y, and z, right? And then you can say, so you have like a thing at runtime calculated a vector, and you can say using a, and then you say just x. So now you don't need to do ax, you can just do x directly, right? And like, how is that different from actually using a module? There is no difference, right? There is no different. So so that's good thing. For enums, I guess it's importing all the variants, and for unions, I don't know what a union is in this language, but I guess it all makes sense. Using can contain modifiers to allow for more fine-grained control over the using. This is useful especially when programs get larger and there are more naming conflicts. There are some modifiers that can be applied to using. Only, except, and map. Except means the using will import all definers found. Except. That makes sense. Wait, what? Look at this. Function is using except x object of type object. It's an argument that you use or what? All x is excluded by the except, so no need to access it by object. All right, only means yes. Map makes a function that modifies an array of strings and maps all the function names to a different set of names of your choosing. Add a character. Array string. Why not just use pattern matching then? The using except x thing, because when you are doing the pattern matching, you need to specify the things explicitly. You know, that's the thing, right? So like think about using the all of the functions from a module, right? It's no different. Do you want to list all the functions that you use here? No, you want to use the star, right? So like by default, the int32 is not in scope, string is not in scope, nothing is in scope. But we want, so like, and print is like defined in stdio print, right? So yeah, something like that. So in the prelude, oh, I'm doing this, right? And I could do the same in every file that is trying to print, right? But I mean, are you asking why is it useful to have a glob import? There is one language that I know that doesn't do the glob imports really. It's JavaScript, right? JavaScript glob import, because even if in JavaScript, if you import a thing, you still don't import that, just that specific part in function arguments. I mean that example is probably not really good, right? Like that's not how I would write it. Sure, yeah, I would do the pattern matching indeed, right? But like having that as a feature, I think is good. Maybe like this is just a minimized example, you know. Although it's weird that they allow it in a function. I would just have a function having the object argument, and then inside over here, inside of this scope, I would say like using that. You like Agda's way of handling? What is Agda? Let's see. Agda module imports. A definition is extended construction defining an entity such as a function or a data type. Module main where, module B where, this, that. Okay, looks like OCaml so far. Looks like OCaml so far. You have three things you can open, followed by one of these, hiding and renaming. Yeah. Sure. Is that what this map is in Jai? Let me see. Map takes in a function that modifies an array of strings and maps all the function names to a different set of names that you're choosing. Why are you saying functions? It's not only about the functions, right? For identifier in array, string is string plus 0. Join identifier 0. This is weird syntax, but okay, sure. Yeah, so like, yeah, they just map it like that. Okay. Yep. It's just mutating the array here. I guess so. Okay, that makes sense. That makes sense. In fact, I think that that this is nice. This is nicer and more generic than what Agda has. And like, I mean, what Agda has is similar to Haskell. Haskell has the same thing. Hiding. I don't remember hiding has the renaming, right? But in general, this can be just a function taking a list of fields and returning the potentially subset and maybe renamed fields which would just be ran at compile time. So like in Jai case, only the map is just a regular function introduced as compile time, and the other ones are hard coded. But like even the except and only could be implemented as a functions and like not as a core language feature, but with comp time evaluation instead. Yeah, hello Veldek. Anyway, for now, before I do that, I think I will still live to that. But the problem is the things that I'm importing, they are either available at compile time or they are not available at compile time, right? So for example, the standard library is basically a constant. Compiler knows about it, compiler can use it, right? But the way I did it here is that it is assuming that this thing is not necessarily a thing that is known at compile time. What does this mean? This means that let me do an example. I'll remove all of this code. Okay, so let's say that we have a thing called foo, right? And a foo is what is a foo? Let's say that it's a module. Do I do it a module? I don't know. I think I cannot. Yeah, I have not implemented the syntax for like the structs yet. So we are going to say module, and then let x be 1, 2, 3, right? So what is foo in this case? Oh, it is actually not inferred, right? Because this must be a constant. Okay. Right. Okay. So can I even do a use foo.star here? Probably not, right? Test eval example. Yeah, I cannot because to do await inferred. Yeah, because like this is not actually inferred yet. Let's do one thing first. Let's do a thing that is comp time. So comp time means that this needs to be evaluated at compile time, so that you know it's similar to specifying a constant. Yep. Let's do that real quick. Syntax core comp time space expression, just like that. So that's it. So the expression that we specify after the comp time just must be evaluated at compile time. That's it. Not sure about the priorities here. Let's keep it like that. Okay, so this should be done like that. Unexpected conc time identifier. But it's not an identifier. Hello? Comp time. Just evaluate. Unexpected comp time. Wait, what? Why? Oh, because of the priorities. Right. I need this to be higher than like the assignment at least. Yeah, you know what? We can make it be. We can make it be anywhere, like over here near the includes. Why not? Priority 9. Okay. So now it says that there is no syntax for comp time, so this is unknown. We're going to go to the compiler core syntax, and we are going to say comp time. Comp time devins dev. Hello. Comp time is we have expression, which is a single child of this one, and then comp time must be expression, I'm assuming. Right? And if we do that, then I want to say that this expression is going to be evaluated at compile time. That's it. That's literally it. So say compiler evaluate yeah, compiler just evaluate. We don't know what the type this should be. Right? So it's a not inferred type, and I just evaluate this expression. And this is my value. And I just return expression constant. Constant just has a value, right? So just a constant value like this. Value and value expression. Evaluated expressions is value expression. This is needed for like the language server. I think that's it. That's the entire thing. I already have the comp time now, right? So there we go. Now we know the type. Because I didn't make like the module type inference yet, so I must evaluate this and compile time first. So here we go. We have the x, which is we have foo, which is a struct, has the foo has x as a field of type int32, right? That's what foo is. And now I can use foo star. And what does this mean? This means that I can have x. Let's just have a like s, which is string, which is like hello world, for example, right? And I can just say stdio print s, right? So now I can print s because I have used it, right? But this is a let. This is a thing that is not really known at comp time. I mean, over here I said that this is known at compile time, right? But this is a let. This is not a const. So so this is not necessarily a thing, you know? I can have like a function. I have like a function f, which is a function that returns this struct instead. And this and foo is just me calling this function like that, right? So this is going to be literally the same. Right? This is evaluated at runtime, and I can use it. And I can use the field of the struct that is not known at compile time. That works. So that's what I mean, right? And that's the same basically as what Jai is allowing you to do. But I'm actually wondering, does Jai has the concept of modules? Is there modules? There is modules. Let's see. Mapping a dynamic library, fairly simple process. Library, pointer, callbacks, example convention, binding generator. Like, do they also treat modules as structs? Is what I'm wondering. Like Zig. When creating a module, you can use module parameters to create user parameters that can be set by the user. Okay, no, module is like a different thing. Okay. And then you can import module with potentially arguments. Okay. It's weird. Sure. So when you import a module, what? You just import all of the top level things in the module? Do you not? Is it like not named? Weird. Okay. Anyway, so the problem is that it's different, right? There is two separate things that I want to use. I want to be able to potentially use the thing that is only known at runtime like this, right? But I also, like in this specific case, foo might be a thing that is known at compile time, right? And in this case, I want to be able to print at compile time. But if I try this right now, if I try comp time, stdio print s, right? What's going to happen? This is going to say that s is not found, right? So I have just tried right now to print the string at compile time instead of printing it at runtime, right? So the compilation failed because I was trying to evaluate this at runtime, at compile time, and at compile time it's not there because this is a normal, yeah, because of the way I've implemented that, right? So how do I let me commit the comp time. How do I differentiate between the two? We can have two different syntaxes for these, or do I need to do two different syntaxes? I don't know. So so the problem is that the thing that I'm using can be any expression, right? For example, I can completely remove this, and I can say something like use function f being called dot star, right? This is completely valid right now, and this is going to fail with the same error. If I try to do this not at compile time, this is going to work because, yeah, so like, I'm just using all of the fields of this, right? So I don't need to fully qualify them. The way I did it in the previous implementation is that this was actually always evaluated at compile time. Yeah, this was always evaluated at compile time, which maybe makes sense. Technically, if I evaluate a thing at compile time that doesn't have, that is only available at runtime, we're going to see the binding there, which should still work actually. Yeah, maybe I don't need to like have a special syntax for it. It's just like this is technically not going to work anymore, I guess. This is not going to work anymore because this cannot be evaluated at compile time, but it will work if I say let foo is f like that, and then use foo star, right? Because this is known at compile time. I can evaluate it. Cast following zig steps, love it. I had comp time from the very beginning. Yes. I'm not really following zig steps. And Zig is not the first language with comp time. But the idea is that, yes, we have everything being comp time. Like, one of the simplest examples is when you say let x be int32 is equal to 1 to 3. What is this? This is an expression. Like, everything is expression in cast. Just some of them are evaluated at compile time, and this int32 is one of the examples. You can just say that this is like, I don't know, let type be int32 and type, right? This will work. You can say std int32, I guess. Then must be yeah. Yeah, I mean, it's supposed to work. There are some missing things for now, though. But yeah, you can write anything, any expression in place of a type. You can do any compile time thing there. Okay. Although, I mean, like, comp time is the keyword that is only being used in Zig, right? So maybe we should rename it to something else, because comp time literally means Zig, right? But what's a better alternative to a comp time? Some languages call it a const. But I don't know, const is wrong, I think. Because const is a constant, something that cannot be changed, I guess. Something is not mutable or something. That's different. Although I did make the const myself. But my const means a different thing. Maybe I should rename the const to... Over here, I'm saying that string is a type. Is a constant type, right? The reason this is const is because const for me is basically a thing that creates both runtime and compile time value. So maybe const is not a good name for it. Okay. Let's not think about the naming too much. Let's just implement this. So basically, I have a use.star over here. Use.star. It was previously just compiling the expression, but now instead of compiling the expression, I'm also going to evaluate the expression. So I'm going to, instead of compiling over here, I'm going to say compiler evaluate. What do we expect? We don't expect anything. Not infer type. Use expression. Okay, then what? Okay, use.star. Hello, Nigel. So now I don't need to wait for the type to be inferred because now I have the full value, right? Available to me at compile time. And I'm going to match the value. Let's see. I'm going to match the shape of the value. Right? Let's see. So we have these are all the values that we have right now. The only one that I care about is the tuple. In any other case, I will say error span cannot use this value print used. Okay. And if it is a tuple, so I'm going to make all of the things available to me at compile time again, right? We have bindings and values available to those bindings, right? Okay, and then the expression, should be this. So use is going to be what, like expression constant of this value. So this is the result expression, and I'm going to evaluate this expression at compile time too. I'm going to just compiler. No, I'm going to say compiler state interpreter evaluate compiler state interpreter result, and then I'm going to ignore the result here. Hello, Jerem. What did I have here before? I need to do probably like the same thing, actually. Can I copy change lines? I feel like actually, you know what? We are going to literally do this thing that I had before, but instead of matching on the type, so like the type is now only needed. Instead of waiting inferred, since I have evaluated this as compile time, I can just say value type of this variable, right? Value type of, and then into inference variable. Wait, infer. Yeah, I guess still I need to wait it to be inferred. Sure. Yeah, that makes sense. And then this used expression is going to be over here. Evaluated expressions is used expression. Okay, maybe this is going to work. Exception, foo not found. Yeah, so now over here, foo is not found because foo, so now this needs to be known at compile time, right? Right. This now needs to be known at compile time. I have not yet introduced the notion of bindings so that I can evaluate the things that are not evaluatable. I will do that also. Right. So for now, but for now, this should work if I do const. This will not work because now this must be const. And this is going to work, right? Yes. Okay. Sure. That's good enough, I think. So now it means that I can use the std prelude star. So once again, the problem before, if I try git stash here, I had a problem before. Why did I need to do that? Because let's say at this, let's try this example, right? Evaluate import 0. So it's going to say that int32 is not found over here, int32. Why is it not found? Because this use is only working at runtime. I need that to be working at compile time, basically. So even although I could make it work by saying std.int32, it should work like that because I have used it, right? So that's why it was needed. So now this example is going to work. Right. Okay, good. Now we can go to the actual thing that I wanted to do today, which is ignoring all the errors. We're going to stop panicking, stop throwing exceptions left and right. We're just going to be able to compile, parse, and evaluate programs even if they contain errors. That's the idea. So why? It's because when you are working with a language and you have the language server, you want the language server to tell you something even although your program doesn't compile, right? But right now it's not the case. Right now if I go to this and if I try something stupid like a semicolon over here, I no longer have, I even lose the syntax highlighting. I report the fact that this is an error, right? But all the other program just is completely lost. So for that, we are going to make the language fail safe. All right. Let's start with what? Let's start with what? Let's start with a parser. So there is like all the parts should basically ignore the errors if possible. Like we should never crash. It's the idea, right? Let's start with the parser. Although there's also Lexer. I think the Lexer panicking is fine for now. So parser can return an error, right? So we have this function error, and what it does is just raising the exception, right? And we don't want to do that. We don't want to do that. So what do we want to do instead? I want to... I still want to report the errors, but I want to continue, right? So this function right now, it returns never. It returns never. But it should actually return something. What should it return? The function should return a unit. And what does this mean? It means that after throwing an error, we're going to continue. So the error is going to be not raised. This is going to be done through the effect system so that we can collect the errors on the outside, and then we're going to continue. So now this, for example, doesn't compile here, right? So I'm trying to parse get name. Token is this. Let me see here. Match token shape with get name. Yeah, this is me parsing a rule. This is me parsing a rule. Okay, technically I do want to throw an exception in some places. Or do I? I don't know. For the rules, it's a little bit weird. So the idea is that, let's say that I'm trying to parse something that is not really parsable, right? I'm trying to parse something that is not really parsable. In this case, we return not an AST, but we return an AST which is like error. We want to have error nodes in the ASTs. This over here is specifically about parsing syntax rules. Which I think for now I can make this thing just fail. It's fine. I don't think I care about this yet. Or like, how can I make this work? Syntax rules being parsed is like over here, right? This is the syntax rule, and when I parse this, let's say that so over here I expect this after the syntax, this thing to be like the name of the syntax, so it can be a string or an identifier. If it is the punctuation or something else, then what should I do, right? That is the question here. Like if we say something like syntax, I don't know, and some symbols like this, and then we still have some continuation, what should then happen? What should then happen? I actually think that wait, I think I can make this work. So I mean in a case we have an error while parsing the syntax definition, I think I should just ignore all the tokens until the next semicolon. Semicolon is specifying the end of the syntax definition right now. So, right. Is there a semicolon in the end? Is there a semicolon in the end? Parse. I think it's where I'm calling the parse. Parse lines, syntax, and semicolon. Syntax. Parse syntax extension. So when I'm parsing a syntax extension, I'm trying to see the syntax keyword and then the semicolon in the end. Yes. Yes, that makes sense. So this means that the syntax rule can also be the thing. Okay. All right. Fine. I feel like I need to handle this not in the actual parsing of the rules though. This is rule parsing. I think rule parsing should just throw an exception. Yes. Yes. But I need to catch it on the outsides. Okay, fine. Fine. Fail. For now, I just fail here. Then this is what? This is me adding a syntax rule to the rule set. So in this case, we can have duplicate rules. If I have duplicate rules, right? So if I specify the syntax multiple times, then instead of panicking, what do? I just ignore the duplicate rule, right? I just ignore it. I report this as an error. And then I say that, what should I return from here? I should just return the node. I feel like I just returned the original node. Unmodified here. Okay, then over here we have unexpected token when I try to terminate, right? So yes, so I have parsed some syntax partially, and then I expect it to be finished, right? For example, I have parsed if condition and then, right? And then after the then keyword, we didn't have any expression specifying what do we need to do if condition is true, right? In this case, we're going to say that we have an expected token like that. If we say like 2+ and forget to add something, we're going to do this. So what should this be parsed as? Right? I think that I feel like this should be parsed as this should be parsed as, should like the entire thing be an error AST, or should I like no I like if I have 2+, yeah, no we cannot not even know what rule does it correspond to. Yeah, we cannot, because there are potentially multiple rules with the same prefix. Yeah, I guess like I guess I just say that my parse result is going to be made progress, and if I made progress with an AST, which is a fake AST, which is an error, I think. So we report this error, and then I say that I return the fact that I made progress, and AST is error. What is an AST? What is an AST? AST has a shape and it has a span. AST has a shape and it has a span. What about the comments too? How do I figure out the span? Parsed rev. And rule collect. Yeah, this is like all my spans and stuff. Yep. Okay, so we need to figure out the span. And we need to figure out the shape. So the shape is going to be error. So we're going to have another kind of an AST, which is, so right now we have these three variants. It's either a simple token, a complex, a syntax extension, or the error now. So for the error, we don't even know anything, right? Or should I know for the error like the tokens at least? Right? Like part list, maybe. The things that I have collected so far. What up, people who have hope in tech? Think we have hope here? Hello, Raymarch. I think this is I'm not sure if hoping that something will come out of cast is you know, but yeah, I forgot to write what I'm doing. I'm doing right now making language making, like, how do I call this? How do I call this? So I want to ignore the errors, making parsing, compilation, and evaluation not stop on errors. That's like, I don't know how to describe it better. So that LSP is more is still reporting, still useful, something like that. That's what I'm doing. You still believe you can fix it? You don't have hope in your own language? I mean, it's fun to work on it. I think that it's more likely that someone else is going to make a language that is something similar to this. Maybe. I don't know, we'll see. Maybe. Maybe I'm just doing it for fun though, right? I'm just doing it for fun. I'm not trying to make. I'm not going to try to make anyone use the language. But if I make it more for myself and it is like usable for me, then maybe someone else will make other people use it. But for now, it's very far from it, right? You watch some more Mojo stuff. I wouldn't be surprised if they are the next big hype link. Yeah. I think Mojo is like actually a good thing. I did actually install it locally. I looked at it. They have dependent types. They have like all of this stuff, you know. So they basically have all the features that I want, kind of. Like, I mean, not all, but they have a lot of features that I want. Mojo can be the thing, yes. But they are marketing it as something that is like about AI, and that throws people off a little bit. While in reality, it's not so much about AI, actually. As I understand. Like the language is actually good there, I think. How hard is making your own language though? Depends. I don't think it's hard. I think it's pretty straightforward actually. It's just a lot of work. Yeah. I don't know. I don't like. There are a couple things that like I need to figure out, but mostly it's really straightforward. Like some of the things might be not so straightforward if you haven't thought about it at all, like type inference, for example. How do you do that, right? If you, but I don't know. I feel like the way type inference worked so far, at least, was really simple. To just unify the variables, it's, I don't know, like you just say that these two things must be the same. It's so easy. I don't know. I think they're just smart enough to know that that's how you get the money. Yeah, so like, yeah. Yeah, maybe. Maybe, right. So yeah, like it's a good thing, right? It's a good thing that they do it this way. Because it means that, so like it means that they can get the money, they can work on the language more because they have the money. You think they're still at the start? I think they have a lot of features already though. I like they already have a lot of features in the language. But in order for it to be like usable, you need not only the language, you also need like the ecosystem and libraries and stuff. I guess Mojo had my support until the AI propaganda. Seems like the future Python, and that would dominate the scene like Rust, but it flopped. Yeah, like that's I think is wrong. Like that's how people see it, but it's not that, I think. You don't hear any dev out there saying I use Mojo as a daily driver. Yeah, they're still working on the language. I don't know. We'll see. You, as I understand, you can try it. You can try the Mojo language. But yeah, the AI propaganda is turning a lot of people off for sure. Like, how do you even get to the thing that is not AI here? Documentation. Like, this is about AI, right? How do I look at the language that's not about AI? That's the difficult part here, right? It's like when it leaks that a game is in development and people use their skewed perception how long it takes to infer that the game is stuck in development hell. In reality, they wouldn't hear of the game until shortly before the release. All right, let me work on something actually. Error. Why cannot not make empty structs in OCaml? Anyone knows that? That's like, I don't know. That's weird. That is weird. Let me see parts here. Parts. Part list. What's a part? We have comment, value, keyword group, right? Is that what I want? Maybe. So shape is error. I need to first print error. Red. Error. Like this. And if I want to print shape, it's going to be the same. Okay, so if I have tried to parse something and it didn't parse, then I need to return the error AST, where parts is, what is this span? Parts is, okay, sure. Let's see, span, unbound value, parts, unbound value. Okay, so parts is, so yeah, okay. We're going to parsed list map part. Is it any better to write Caspian or Camel rather than mid-rust? What's mid-rust? I don't know. I kind of get used to a camel. I think the problem, but maybe we'll see. Like, I think that Rust code is easier to read, but maybe I will change my mind over time too. Can I do that here? Okay. Value. Keyword. The language appears to be quite based in terms of its design decisions, and they have rolled the whole MLIR thing going. I personally have never held strong feelings with relation to syntax. I know people hate Python whitespace stuff. Yeah. Is there any other MLIR language? MLIR. Is this the one, right? From LLVM? What are languages that use MLIR? Swift for TensorFlow RIP. Is this all like for AI? Tensors and stuff? I just desperately hope they don't have Python lambdas. Let me see. There was there a thing here about Mojo? Over here. There was a creator of Mojo somewhere. This over here. Chris Latner from the Modular team. Mojo is a general purpose language. I think they said that it's not really like Python anymore. They oversold Mojo as a Python superset too early and realized that we should focus on what Mojo can do for people today, not what it would grow into. Wait, it's trying to grow into a Python superset? They've invested in a lot of nice generic system features. They have metaprogramming, dependent types, linear types, and other features that mainstream languages don't have. I don't remember. I thought that he said something like it's not really Python anymore. I don't know. I don't know. I don't know. I have only tried a Hello World in it so far. I cannot say much, but I think Hello World compiles slower than my Rust code base. They said you can call to and from Python. Yeah, maybe. All right, let's not talk about Mojo too much for now. Maybe a little later. When they like have some, I don't know. They are committed to open sourcing the compiler. Yeah, the compiler is also not open sourced, right? They are committed to do this by the end of 2026. Maybe that's when we try Mojo. Was that a joke, or were the compile times really like that? We can see. Let's go. Temp. Past. Git checkout. Mojo. Mojo. No? Let's see here. Yeah, there's like a little weird. They are using like the Pixie Python stuff, right? Pixie shell. Yeah, I need to go to the Pixie shell to download like the things. I'll show you. I'll show you. And then over here inside of the Pixie shell, we can do Mojo, right? Could not start dynamically linked. Acceptable Mojo. That's weird. Do I do Steam run? Pixie shell? Sure, let's do that. Yeah, because like the compiler is not open source and stuff. You need to like download the things. Mojo. There you go. Okay, NeoVim. Let's see. So what do I have here? I have Hello Mojo, right? Here's the thing. Here's some Mojo source code. Here's some Mojo source code. We generalize. We create a struct which is copyable and removable. This over here is basically a procedural macro that generates me the constructor with all the arguments, right? And then we do some formatting like that. Then we print it. So Mojo, hello Mojo. Time. 0.4 seconds to run it. Is it compiled already? Is there like a Mojo compile? Mojo help. Mojo build. Mojo build. Hello Mojo. Yeah, there you go. And then we can just have a hello binary like this. The binary runs fast, right? And then Mojo build. This is doing it from scratch though. Like I want to make sure That is like not reusing anything before timing it. Hello. Time Mojo build. Hello Mojo. It's half a second. I mean, if it doesn't scale, half a second is pretty slow for a Hello World, I would say, right? But if it doesn't scale on big programs, then maybe it's fine. But Rust Hello World is compiling faster for sure. But a large code base in Mojo, I don't know if it exists. Is there something written in Mojo that I can clone? Maybe on GitHub. Can I just search for a language? Mojo. Need to design your language to compile on the GPU. Compile on the GPU? Not run on the GPU. I want to run on the GPU. What about compiling on the GPU though? But I mean, if I can run on the GPU, then I just compile the compiler, and it just works on the GPU, right? I mean, just not everything can be done on the GPU that can be on the CPU, right? How do you read a file from how do you make a program run on the GPU that reads files? You don't do that, right? Learn GPU program by solving puzzles. Problems. All right, you know what? Don't distract me with your Mojo. we need to work. No Mojo. Alt F4. Made progress. So parts is, so this should be AST like that. There you go. Okay, span. Span is parts list head dot span start. Span is span. Is this is the start. Finish is parts list last span finish. Just do that. What is Shame? Shame is a Ray Marsh's project, which is the metaprogramming language that compiles to that allows you to program the GPU, I guess. Parts. This expression is type AST part, which is not a record type. Fuck. Okay. Spans. Let spans be parts list function comment span and value span keyword word span. Good enough. Group. Actually, you know what? I'll do this. Mm. Raymarsh not using Nyx. What a shame. All right. What is this? Spans. Dot start. Dot finish. There we go. Okay. Let's do the work. So once again, I'm trying to make the language server not stop working as soon as I type a single character, which makes the file no longer compile, right? That's the idea. So we're going to have the error ASTs, error like error AST nodes. So we continue parsing even after seeing the error, is the idea. All right. So whenever I try to finish, and I cannot, we report the error, and then we just return the error node, like this. Okay. Now, what is that? The pattern matching is not exhaustive. There is the error. Yeah, so now we have the error nodes, right? Start priority. Start shape. Continue with. So I'm trying to... I have parsed an error node, and I'm trying to see... I have parsed the error node. On the first iteration, we need to check that the start value satisfies the previous filter. All right. So if I have the AST error node, I think I return none here. Okay, sure. Wait, is that it? There is no way this is it. No. I also need to like skip some. I'm pretty sure that I need to skip some tokens. Well, after I see the error. Let's fix the other parts though. When I'm trying to compile an error, for now, if I'm trying to compile the error token, the error AST node, I'm just going to report error at the span, saying trying to compile error node. Yeah, I just visited the website for CAS and was wondering what are the compilation targets for the language, but I didn't find anything about that. There's a section compile interpret, but I didn't understand anything from it. Yeah, the compilation targets is going to be both native target and some other targets. I was planning to go for the JavaScript as compilation target. There is there are plans to do the native compilation, but I don't really need it personally, so it's not going to be a high priority. And then there is the interpreter. So interpreter is another compilation target, which is needed anyway to run code at compile time. So we begin by making the language purely interpreted, and then we add the compilation target for it. So interpreter works on the intermediate representation, which is very high level, almost just AST, but with type inference and some other stuff. And then we will lower that to other compilation targets. And the idea is to have the language expose an API so that you can write your own compilation target in the language itself. So you can inspect. So you can basically write a program that compiles. Like basically, what even is a compiler, right? A compiler. The idea is that the compiler is the interpreter that just spits out the binary, for example, if you're compiling the binary, and having the compiler as a library, basically. Have I considered WASM? Yes, I have considered WASM. I don't like WASM though. WASM is not ready yet, in my opinion. They have a lot of things that are only proposed and not yet implemented. That's why I would prefer JavaScript. There are some proposals that are not there yet. Like for interacting with the browser, you still need to interact with JavaScript right now. You cannot go with purely WASM at this point. There are other things like exceptions or like jump stage. There is no jumps in WASM, which makes certain things difficult. There is a proposal to add that though. But for now, WASM is just not... Like, there's too much work to make it work, basically. So, yeah. Whatever. JavaScript is just easier to generate. It has more features than WASM, which makes it easier, right? And like in general, compiling to the native, like compiling to like assembly and LLVM, I think it is even more work, but we'll see. There's also this idea, now that I am rewriting the language in OCaml, so let's say that I will want to rewrite the language again in itself. And how do we do that? Do we make the language and then we rewrite the entire language from scratch? Or can we somehow make it incremental? How do we make it incremental? How to only rewrite a part of the language and not the entirety of the language? So the idea, maybe instead of going for JavaScript, what if we just go and transpile the language to OCaml, so that I write a part of the program, a part of the compiler in Cast itself, transpile it to OCaml, and just replace some existing part of my compiler with code that is written in the language itself, you know? So I think that's actually a good idea. And OCaml is simple enough language, I think, to use it as a compilation target, actually. Shouldn't be too difficult. Progressive self-hosting. Yeah. Because otherwise I will just need to rewrite the entire thing from scratch and keep working on both the new compiler and the old compiler, right? But like if I do it like that, then I can just replace the lexer immediately without replacing like the other parts. I think that makes a lot of sense to do it like that. Pattern matching is not exhaustive. If I find spans, start from the biggest. This is the LSP stuff already. Error. I guess for the error, I just don't do anything. Is my lexer complexer? What's complexer? Is that a joke? What's a complexer? Is that a thing? Complexer. Complexer than the average lexer? No, my lexer is currently really simple because I don't care much. I need to actually make it more complex to, like, I didn't even add the raw identifier like stuff yet there. But I was also thinking about, similarly to how the parser is extensible, I was thinking of making the lexer extensible, so that, like, because imagine if, like, if I actually want to, inside of the language, to have another language embedded, right? Like inside of HTML, have a JavaScript, right? So HTML lexer and JavaScript lexer, are those the same or are they a little bit different? And so if you want to have a language that is that needs like a different lexer to be embedded inside your language, you need to temporarily change the lexer, right? Something like that. Because right now I can only use like a language inside that is using the same lexer. I think I'm gonna get banned today, but honestly, I'm gonna work on my language because of the Endless Debian logo. Learning curve of Rust, and I'm planning to not even use Rust for my language because Rust is so frustrating that it's just garbage in total, unlike Go. It's like a garbage collector and it's not really useless, but Rust is the garbage inside of the garbage collector. What? I didn't even understand. Do you think I'm going to ban you because you say that you don't like Rust? I don't like Rust either. I don't like anything. It's more difficult than that to get banned in this chat. Indeed. You need to try harder. You need to try harder. At least try to, like, say that you don't like the language that I'm making here, right? Say that the cast that I'm making here is garbage. Try saying that. And even then, I don't think that you will be banned. There is no reason for that. But it would be nice if someone thinks that the language that I'm making makes no sense to them, then you should speak so that we make it make sense to you, right? You don't think you are making garbage, but I am making something that is heavily inspired by Rust. In the fact that I will have the borrow checker. That's the idea. My borrow checker is going to be a little bit different than in Rust, but also very similar. Then it's garbage. All right. So you are saying that you have a skill issue with the borrow checker, basically, right? I have yet to find out how Go got so many people excited. I think it makes sense. Go is like stupid simple. And a lot of people... Like, I mean... That's the entire point of Go, right? So that even a monkey can code in Go. Like, people don't like learning, right? People just want to make some money, and Go allows them to make money, right? You don't need to do some like I get the borrow checker, then I have some trouble with Rust-nomicons, and then when I clear stuff out, move to the next chapter, my brain just doesn't understand the alien language. And then the learning curve increases. I guess it will take 2 years for me to understand Rust, which is a waste of time just for memory safety. I think Rust is, like, I'm not using Rust because of memory safety. Memory safety is just the side effect of Rust for me. I don't care about performance of Rust. I never cared about that. It's just a language that allows me to write code in a way that I am more confident in it. It catches more bugs for me, and it's not only about memory safety bugs. Side effects mentioned. All right, so what do we do here? What is this? Matches. AST expected. Oh, this is a test. When I'm testing, I probably don't expect to see any errors, right? So if I see error and anything else, then we are going to say that it doesn't match. All right, there we go. I never expect an error in my tests. Collect AST into token sequence. What is this? This is semantic tokens. I guess for semantic tokens of the error. Let's see. I need to do something similar to this. But all of the parts are going to be error parts, I think. Or not all of them. Actually, not all of them. Hold on. I guess this should be an AND here. Parts. List to sequence. Sequence lat map. Match function. It's similar to the collect group here. Collect. Oh, maybe. Okay, this should be collect parts actually. Yeah, that makes sense. That makes sense. Collect parts. Where parts is what? So this is like AST part list, right? And this should be collect parts group dot parts. Okay. And then over here, just say collect parts. And over here, collect group root parts collect. Matches like the little stick of fire. Oh, bad cop. Hey, you have error? I'm going to ignore it. Print AST. Whenever I print, this is highlighting. When we want to highlight the code and we see that we have an error, what are we going to do? I'm going to print the parts there. Okay, so this should be print. This should be print parts, where parts is st part list, like this. Parts print parts group parts print parts root parts. If we have error with parts, then we print parts. Didn't know you could just ignore errors in Rust and it's like TypeScript. Yeah, that's what we're going to do. We're going to actually make it like JavaScript, not even TypeScript, like JavaScript. I'm going to be able to evaluate code which has errors. So we should be able to actually write some code like 2 plus 1 to 3 like this as string. But this will evaluate to the value that is error, unlike JavaScript where this evaluates to 1 2 3, right? We just say that if something doesn't work together, we are just going to have a special error value. But then you use a Rust library where they just decide to use panic for API usage errors, and then your application's crashing mass and you don't even know it. Right. Yeah. Which, by the way, like, when I just opened this Mojo code, you see this immediately is better than Rust, right? The, hold on, temp cast. Did you notice that in the Mojo example over here? You have the function main, which actually has the keyword raises. This is basically saying that the function can panic, which is missing information in Rust, right? I wonder if like they have it more precise, where you can specify the type of errors that can be raised there, because that's literally like the effect system, right? That we want. Wait, does Mojo have the effect system? I don't remember. Does Mojo have effect system? Nope. Do they have monads? Nope. I'm pretty sure they have monads though. I think ChatGPT here is wrong a little bit, but maybe maybe I don't remember. What happened to verse? I don't even know what a verse is. Verse lang. Oh, is it like the Epic stuff? The Unreal Engine? It's just 2 years old. Maybe they are developing it in private. Okay, did I compile yet? No. Cast formatter. So whenever we want, how do we format the error? How do we format the error? I don't, right? I don't format the error. Fail. Cannot format code with errors. I think that's fine. Okay, it compiles. Let's see what happens. Let's see cast parse this thing. So we can still parse an example like this, but let's try to have a thing that doesn't actually parse, right? New file doesn't parse.ks. So we say like 2 plus, right? 2 plus 2 works, but 2 plus doesn't work. So what's going to happen? Okay, so we have parse error, unexpected end of file. Okay, that makes sense, because parse error. We need to go back to the parser. We need to change the behavior of the error function. Error function right now actually raises the error, but instead of raising the error, we should have effect perform. Effect perform error. Effect perform error. Like this. So error now is not going to be an exception. It's going to be a resumable exception, which is what an effect is. Like this. So we no longer need to do that. Okay. We need to actually handle the errors. Yeah, so error is actually is of type error into unit effect t, like that. Okay, and this should be just me printing the error. You know what? We should have a module error. Struct like this, and then we just include. No, we just say that. Let's actually, yeah, let's move this to like its own file to error. Oh, do that. Open std, open cast util. I don't register the printer. I just say that this is type T and type rst, and then we have print formatter error unit is function empty error into f this. Error message, error span, like that. Okay. Now I want to basically say that let error be error, right? Can I do that? Expect in the file. This also says raise error. We rewrite link cider in cast soon. I don't think so. Do we need to? We can write cast link cider 2 in cast though. When you evaluate a binary operator on two different types, you should ask ChatGPT to generate a third type for the result. Oh wait, hold on. I saw this the other day. Hold on. I saw literally this idea the other day. Somewhere. I saw this the other day. I'll find it. Hold on. Can I find it? Like someone actually made a Python library that allows you to do that. Have you ever written a thread-safe socket programming code? Maybe. What does it mean to write a thread-safe socket programming code? I've been mostly writing Rust for the last 10 years, so like all of the code is thread-safe because I basically never use unsafe. So maybe not is the correct answer here. Because when I was writing C++ and I was doing some sockets there, I was not doing multi-threading. Because I don't want to write C++ and multi-threading. That's like pain. My code is thread safe because I don't use threads. Yeah. Well, I mean, I think it's not that difficult, but I don't know. Alexander the platformer, hop legs. I saw the hop legs. Wait, did I get the hop legs? 60% off. Hold on. 60% off. I'll never play it actually. Wait, is there? Oh, there's a summer sale right now, right? Everything is off. Of course. Of course. 159. What? What? The that rubles? Yeah, that's rubles. Error. Okay, raise, not raise, just effect, perform error dot error. Can I do that? Yes, I can. Okay. Yep. Okay, now we have unbound type constructor error. Parser error option. Parser error, I'm just going to say over here, type error. Type error is error t. Okay, do you compile now? You don't compile. Parser error, this, okay, yes. Yes. Wait, this is like so weird. Like the fact that I cannot import the constructor is actually really weird. I will need to do parser.error.error here. Or I can just include the entire error module, but that doesn't work because I don't want the print function to be imported. That's weird. Okay, let's just say module error is error. Okay. So this is now not an exception. This is an effect. So now when I'm processing the file in the language server, and I see that there is an effect, this, with continuation, I'm actually not going to continue for now. We're going to do that. We're going to treat it as an exception. But later, it will just store the diagnostics, and we'll continue further. Do store as diagnostics, because I want to do the other thing first, which is, yeah, this is the test. If I have the test, and we have effect that, that's fine. Parser error.error. Okay, that's fine. Continuation has properly failed. Sure, we had the parser error. Okay, that works. Pi 6, didn't they learn from the Python 2 to Python 3 disaster? Wait, what? Is that a joke about the rubles? I guess. Game is like 70% cheaper. Yeah, because it's called regional pricing. It's even cheaper in some other countries. Yeah. Basically, you live in the most expensive place on Earth, Bad Cop. So everything is more expensive for you, including rent, including games. But you also earn 70%. But I also earn 70% less money than you do, right? At least, probably. So if you move to Russia, you can buy a bunch of games and then move back. Yeah, but it doesn't work on Steam like that. If you move between regions, then you can only play a game in a region where it was bought or something like that. I don't know like the exact rules. Like they disappear from your library when you switch regions. I think. Because I think in the past people were abusing the Steam for that. Like you know, you can gift a game to another person, so people were gifting from another country, so that because it's like cheaper in another country, right? Is that why you don't want to move? I mean, that's part of the reason. It's kind of cheap here, right? If I move, I will need to have a job and I will need to work instead of streaming, right? You cannot gift across regions. Yeah, I mean, you cannot gift any more across regions. I think you could gift across regions before. And then they, like, removed it because of that. But if you move, you would lose Steam library. That's the deal breaker. True. Okay, raised by primitive operation, the exception unhandled effect parser error. Okay, parser error is now the unhandled effect. Let's have in the CLI in main over here. I'm going to handle these effects. Effect cast parser error underscore k. So if we have an error in the parser, let's just continue. Let's just say effect continue. Okay, like that. You know? Yeah. Let's do that. I probably should like report the error though. Let's just log it here. Log error. What are wait hold on. OCaml format. Can I just give it a function? What are all the percent things that I can use? Where is it documented again? Somewhere in like in a printf, probably. How do I go to the printf? Why is this search not working? Printf. Percent. To prevent the representation of this, not with percent character. Percent. Where's like the list of all of the percent things that I can use? Please, please. Documentation. There's %a conversion. But what is like... Just as the DC out? True. I think it's like somewhere else. It's documented somewhere else, not in this module. Printf module, maybe. Percent flags, yeah, there we go. The types and their meanings are di, u, this is integer, x, convert an integer as string, f, floating point, g, floating point, h, floating point, b, boolean, ld, int 32, and d, native int 64, user-defined printer. So user-defined printer order always takes 2 arguments. T is the same as A, but only take 1 argument of type out channel unit. Yeah, there we go. That's what I want. A %t. Right? So %t error. Message. No. Wait, actually, %a. But cast parser error print error. There we go. Actually, just this. But this one can be a T. This one over here can be a T, and you just can do just error message then, right? Because that's a function that takes the formatter. Yep, that's easy. Okay. So let's see what happens now. Okay, so now we have the parse error unexpected end of file, but then we have another error. Oh, yeah. So, yeah, okay, now, that makes sense, right? So this entire thing is the error node, right? So what do I do if I say 2 plus? This says that this entire thing is the error. I still like want to see something, right? Some like not the entire thing should be just a huge error node, right? But in this case, this has not been finished, right? So it technically makes sense. 2 plus 2 plus 2, this has been parsed successfully. If I say 2 plus, and then over here I say 2 plus, like this, like, then I want to see that I want to add 2 and an error node over here in a scope, right? Yeah, okay, hold on. It actually works. Look at this. So we have a add to and a scope, and inside of the scope we have the error. That makes sense. Right? That actually makes sense. That's how it's supposed to be. But what if we say 2 plus plus here? Then it will say that I'm adding 2 and the error node. So the entire thing over here is the error node because this could not be finished. Right? And then also, like, it did literally stopped parsing at this plus plus symbol because it is not defined anywhere, right? And then it says like unexpected end of file, right? And we got plus plus because we have only parsed until this. So that's what I mean. We should basically skip tokens until like whenever we see an error. Wait, how does this work actually? Hold on. How should this work? So it has, we see 2, right? We see that this bracket is not closed. So should I just skip until the bracket is closed? Not really, right? What if this bracket is never closed? What if this bracket is never closed? How do the things like tree-seeder do that? I have a feeling that the brackets should be a little bit special case there. Like I can start ignoring the tokens until I see a thing that can continue my current thing, right? But let's say that we have like let's say that I had a code like this. I say like print hello world, right? And then so like this is parsed successfully, right? And then I say print plus plus hello world, right? Should this, like, what should this be parsed into? Right now it has been parsed into a single print identifier over here, and then over here it just stopped. By the way, that's wrong. It should result in wait, I mean, actually, this is fine. We report the error, but we still like have parsed this successfully. Maybe this is good enough, but I always want to parse the entire file, right? I always want to parse the entire file. So what do I do on the like on the things that I don't know what to do with? How does tree-seeder and similar parse code which contains error? Error-tolerant grammars. Reproduction in grammar. Grammars explicitly define how to... Oh, hey, grammars written for TrueCenter explicitly define how to handle syntax errors, really? This allows the parser to consume the garbage and move on. Okay. When there's an error, TrueCenter doesn't quit. It inserts error nodes into the parse tree to represent the broken parts. These nodes are marked as error, and tools can use them to highlight problems or recover from them gracefully. TrueCenter uses it as GLR, inspired LR parser, meaning that it hits ambiguity or junk. It tries multiple parsers. It picks the most valid looking one. It uses look ahead and cost functions to pick the best path, even with the bad tokens in the mix. Yeah, I'm not doing like multiple tries right now. Incremental reparsing. When you fix the code, TrueCenter doesn't throw out the whole tree. It reparses just the changed parts. It is fast and responsive in the IDEs. Maybe incremental reparsing isn't really needed yet. Example, parsing if x is more than opening bracket. This doesn't belong here. Fine, I'll parse this and then I'll mark this as an error, wrap in a node, and keep going. So what should happen? What should happen? What will happen in a language like Rust? I cannot see the internal representation there anyway, even if I open the IDE, right? Like, there are two separate things. If I open the brackets here and if I don't open the brackets, right? Like in this case, it will say that, yeah, I have applied argument is the error, like that. I have parsed the opening bracket, but the closing bracket has not been parsed, right? Okay. I feel like, I don't know. Like, I should skip and then also I shouldn't skip at the same time. It's weird. Like, if this closing bracket is not here, then maybe maybe I'm missing the like maybe this code over here is what I have started, and I'm just typing it right now, and then I wanted to close this, right? Or maybe the bracket should want it to be closed over here. It's actually, yeah, I don't know how to deal with this. So okay, the other idea then, maybe we so how do the LSPs work like that then? I don't get it. Anyone have built the LSP with working like that? Like, for example, at some point our code was compiling successfully, right? Maybe we we remember the point where the code was parsed and compiled successfully, and then we see how the code was modified, right? By trying to match the previously parsed thing with the new thing. Is that how you do it? I remember the creator of the anti-language was building something. Let's see this. This is stuff by the anti-language creator. This is a learning resource meant to show a possible architecture for the compiler that is incremental, concurrent, and fault tolerant, right? This is the part that I'm interested in right now, being fault tolerant. So it takes into account the recent move away from the traditional pipeline-style compiler towards a demand-driven compiler designed for faster rebuilds with a language server in mind. Fault tolerant. Parser always produces a valid AST. If there are errors parsing, it will also return a list of errors along with the AST. For example, if there is a syntax error at a top-level definition, the parser will recover by emitting an error and skipping the tokens until the next top-level definition starts. In practice, recoverable error parsers are essential if you're writing language server where syntax errors are very common mid-edit. But so yeah, I think this over here, this depends on the language a lot. Like if I am making a language which knows like how do you skip the tokens until the next top level definition starts? That means that you can detect the top level definition, right? That means that you can detect the top level definition. The only thing that I can detect is, so I'm currently doing the parsing, and I can do one of the two things. I can either start parsing a new AST node, or I can continue parsing the one that is up the stack, right? So for that reason, we actually have the thing that is called continuation keywords. Right? So I know that plus plus cannot be used to continue parsing anything that we had before. It can also not be used to start anything new. And that's why we're just going to skip it. Maybe that's the thing, right? Maybe that is what I should do. I should just skip it and I should continue trying to parse the stuff. Yeah. I think that makes sense. Parser. So basically I'm saying that when I'm parsing, first I'm trying to follow with a value. Yeah, and then I'm over here trying to follow with a keyword. Right? So if a keyword can be used to continue something up the stack, then we don't go there. If it is something that can be used to continue the current AST node, then we do that. But what happens if I cannot do this and if I cannot do that, right? Yeah. Yeah, so like over here, if I have not done that, so if there is no edge like this, continue with edge, next. Okay. Let's do this. Let result be this. In result. Or rather, I'm going to match result. And if I have not used this keyword here, it means that this keyword... Oh, and wait, hold on. If it... But if it was used here, then I return early. I can also try doing this with a value. Hold on a second. I'm not sure how to write this logic. So I am... This is returning parse result. Parse result is either I made no progress or I made progress and calculated an AST. Right? Yes. Yeah, over here, terminate node. So like if I have not made any progress here, then it means that I want to terminate. And this is where I said that if I could not terminate, then I'm returning the error here. But I'm not skipping the token. But maybe I should be skipping the token. But maybe actually before the terminate, because maybe then I will continue further, right? So over here, I have... okay, so I have not made a progress. I cannot parse the current thing further. Should I skip or should I not skip the token is the question, right? So, yeah. Let should skip token because of the error is the question, right? Should skip the token because it is an error. So if I should skip the token, then I do one thing. Otherwise, I try to terminate, actually. And if I should skip token, then I say Lexer advance. I will say Lexer advance. The should skip token. I will report the error of the token span. Unexpected token print token, right? And that. And then after advancing, I will just try to continue further. So just go recursively, go node, right? Yeah. So when should I skip the token? Should skip token, because error. If I cannot use this token to either start or continue anything, right? Anything else. So continuation token keywords string map contains string set contains raw token map or false function raw in the raw. No, contains but not, right? If it doesn't contain, then it means that I cannot do that. Okay. And also, I should not be able to start a new thing with this keyword. I should not be able to start a new thing with this keyword. Right? And so, like, how do I do that? Rule set. Root. Next keywords. String set contains raw. I think just like that. Let's see what happens. Okay, so now it says unexpected plus plus, right? Over here, unexpected plus plus. So I have skipped it. Then it says unexpected closing bracket. But why is the closing bracket unexpected? Because closing bracket is definitely expected here, right? But I have oh, it says unexpected end of file 3 times. And the error is the entire thing. So I have parsed this thing. Which is weird. Hold on. I have parsed this thing. Oh, wait. Maybe because I skipped that token. I think if this token can be used as a simple value, then I should also not skip it. Match token shape. Like if it is an identifier. If it is an identifier, then it can be used as an identifier. Let X be this in match token shape. So if we have punctuation, then it is just this thing. If it's an identifier, I should not skip. If it's a string or a number, I should not skip because they can be used as single values. If it's a comment, it's kind of unreachable, right? And if it's end of file, then I also don't skip. I think it's only about punctuation here. So it's still, but it still is the same, right? So I have should like log what I am parsing here probably. Unexpected plus plus. So we have the unexpected plus plus. Then I can continue from the opening bracket like this, right? Oh, because wait, hold on. This is also not parsed. Wait, why is this not parsed? That makes no sense. What if I say git stash and then try to parse this? It parses. So I actually broke the code, right? I actually broke the code. Okay, what did I do? Like, unexpected opening closing bracket. But there were no errors before, which means that I have not skipped anything. Right? Unexpected closing bracket. Let's see log trace. Let's see log set max level trace. So we started. I made progress. I have parsed the print over here. Then I followed with the opening bracket. Then we finished. I made progress. I parsed this thing. And then it says unexpected. Because oh wait, oh, because I started to parse one. Okay, that's why. Because I started to parse one. Because yeah, I'm trying to like see if this Because this cannot be the beginning, but this is a continuation of the opening bracket, right? Oh, but continuations get deleted. Continuations actually get deleted. Over here. You are a continuation, Pigorli. Low. Continuation keywords. It's empty here. This is wrong. It should not be empty. It should still be, even if this is any, it should be this is my next node. Should be next keywords. I think that's what it should be. Okay. That kind of worked. Now let's try introducing the error here. So I say plus plus. And what is this going to be parsed into? Okay. So this has parsed as printing the argument which is inside the parentheses, just error. And this entire thing is the error. But how is this an error if this is just a string? Right? I have skipped this thing. Oh, because I was trying to read this simple value, right? Yeah. Wait, what? No. Yeah. No. Uh-huh. Let's see the log. What was happening here? Let's actually remove this and make this even simpler. Let's just say plus plus hello world. What is this going to be parsed into? Just into error. But it should not be error, right? Hello Brainoid. So we say unexpected plus plus. Then I made progress. I have made the progress. I have read the hello world here. Right? Yeah, so we followed with value hello world. So I had a value. Hello world. So I had a single value. Finished parse 1, no progress. Yep. Because it says unexpected in the file here. Okay. So I have parsed this thing. Yeah, I have followed with value. Maybe like doing this can be postponed. This is difficult. I need to like, if I have only parsed a single value, that I should be actually terminate, right? That node should be terminal, technically. But it's because like it thinks that I made progress, right? That's why. Let's see what happens. So we say let's start. So I have tried to parse simple. Parsing simple did not work, right? And so since it's not a simple one, and then we just go from the root. Yes. Even though it should have been a simple one. Makes sense. I think terminate should actually terminate. Even if node is not terminal. Even if node is not terminal, we should still terminate sometimes. You know, because I have only parsed a single thing. So we have parsed parts. We have parsed parts, which is comment, keyword, or value. And if I have only a single value, then I should just return that value, right? So if parsed let single value is parts ref into list fold function found part into match part with, if I have a comment, then it's just act. If it is keyword, then it is going to be some none. If it is value, then it's going to be match act with none, some value. And if it is some, anything, then we say some none. And we fold left with accumulator starting with none, and yeah, like this. So single value is an optional AST, right? Yeah. So if I'm going to match single value with, if it is some AST, then I will just return progress AST. In any other case, we will do this thing I was doing before. Does that make sense? It worked for this case. It works for this case. I should have more. We have tests of the parser actually. Simple syntax cannot be parsed now. Okay. All right. Oh, because there's also the syntax keyword, right? Is that why? Or no? Unhandled error. Fine. Let's do try. Parser. Effect. Parser. Error. I'll just say that we're going to log error. Effect discontinue continuation with failure string sir error and error. Yeah, so it says unexpected closing at OCaml test 116. No, I do have the rule set already. So it's like it's the source, right? At 1617 OCaml test. So like this thing. This is the test. A is 1, B is 2. I guess this one, right? Because I'm parsing the simple syntax. So on this one, column 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. This closing bracket was not parsed. It says unexpected closing bracket. But why would it be unexpected here? Because I have a bug. What if I just try parse something? Parse something else, right? So this says unexpected plus plus, but then it successfully parsed the hello world, right? Let's do other things. So we have print and this in parentheses, right? Is it going to say that closing bracket is not expected there? No, it actually has successfully compiled it. Like I don't see the error tokens though. We should have like the errors. I mean, yeah, there is parser error. Yeah, there is parser error, but it still is has returned the successfully parsed AST, which is like this doesn't exist here. Okay, maybe that is what we want. What if I open the brackets twice? Then it doesn't work for some reason, but this should actually be the same, right? Yeah, why is that? That makes no sense that this doesn't work. So it says that the closing bracket is actually unexpected. Yes, why is that? This the second closing bracket is unexpected, not the first one. Wait, hold on, the first one. Yeah, so we followed with value hello world over here. And then the closing bracket was not used, right? So I have opened. Closing bracket was not used yet. It is unexpected here. Followed with value hello world, and it's unexpected. Yeah, I understand. It is unexpected. Start parse one, finished parse one. Start parse one, finished parse one. Made progress. Hello world. Followed with value. Hello world. Unexpected closing bracket. and make progress is this error node. So this opening bracket was parsed and it was not closed for some reason. No, it is, yeah, it's actually like the inner closing bracket that was not used. But why? Isn't this literally the same thing? It makes no sense. That makes no sense. If I have like 5 opening brackets, that should work the same. What if I remove the plus plus? Oh, if I remove the plus plus, it doesn't work. Okay, I broke it. So we just parse the hello world, and then it says unexpected closing bracket. Which makes no sense. Because it is the continuation keyword. I understand now. Because I said that the inner continuation keywords are these keywords, which I can use to continue my current thing. But if I can continue my current thing, so it means that I will not try to continue my current thing. Makes sense. Right, so that's a bug. So that's why this was here string set empty, right? So I should just ignore everything, right? I'm lost. Stash parse. Right, this is parsed. This was parsable before, and then I broke it. Do I need to rewrite my parser from scratch again? I mean, not from scratch. I just stopped understanding how it works or something. What did I know what I'm doing anymore? Node next keyword. Next keywords. String set dot empty. Unexpected. Skipping unexpected. Let's do that. Am I actually skipping unexpected? Yeah, I'm skipping unexpected closing bracket. Yeah, so I skipped both of them. I skipped this one and I skipped that one, right? And why is that? This is because this one cannot be used to start a new thing. It cannot be used to... Wait a second. Wait a second. It is punctuation. Continuation keywords doesn't contain this? Is that what you're saying? But continuation keywords should contain that. Let me do log error. Continuation keywords is list string print continuation keywords. String set to list. So this is my continuation keywords. We have a wait, what? That is completely wrong. All of the things. That is wrong. Okay, I think maybe like over here I actually made a, yeah, the continuation keywords, inner continuation keywords. This should not be. Hold on. The edge is with the value. I'm going towards that edge with a value, and then that. Wait. Next keywords. No, that actually makes sense. Oh, wait, but for the first one, the only continuation keyword that I have is a comma. When I skipped that one. Why is comma... Or is this just an empty list? Maybe. And dbg. It's just empty list. Because we cannot continue with anything. It was empty. Because over here, it said empty. Not continue with anything. And so I skipped it. But I can continue, like, but I can over here, right? So the continuation keywords don't contain that. And the keyword, maybe like continue with next. I'm lost a little bit. So I have parsed this thing until the hello world. Then I see this closing bracket, right? I have been parsing this thing as the inner expression inside of this bracket, right? I see, what can this be continued with? Well, this can be continued with that, with like all the things. Yeah, no, it makes sense. Yeah, it makes sense. Like, okay, I should actually not... I should have a separate continuation keywords or something. Maybe. Like, so the reason for the continuation keywords to be here at all is that the parser is greedy. So, if we have, I don't know if we have an example of this right now. if I have syntax for if I have syntax for 2 plus 2, right? Or like 2 minus 2, right? 2 minus 2 is a syntax, right? But also negative 2 is also valid syntax, right? So when I see this, and I see this minus, should this be the beginning of the new expression, which is minus 2? So should it be parsed like that? Or should it be parsed like this is the whole thing, right? So maybe that's the correct example here. So we actually don't start parsing this as a new thing if this can be used as a continuation of something previously. That's why it's called the continuation keywords, right? But then I reset the continuation keywords whenever I basically see the parentheses, because we reset everything. We reset the priorities of the expressions that can be parsed here, and yeah. So like we cannot continue something that was started like outside of the parentheses technically, right? But I still should be able to continue with this bracket. But I also remove that by saying that it's empty over here. That's why I was trying to do these next keywords, which will just include the closing bracket there. Let's remove this. So once again, I have parsed the hello world. Then we see this thing. It's unexpected. Oh wait, this is just unexpected. On 24. Unexpected. Yeah, this is not skipping unexpected. It's just unexpected. The skipped one is the last one. Wait, what? This is a different one, right? Unexpected. Over here. So I have a. I'm trying to terminate. And I am saying that this is the error, right? So I have an opened bracket and followed by the string, and this is error. Okay. I think I can I can do a little bit better of a job reporting the errors though. Let's do that. If I have an AST, and I want to print the AST, if I want to print the AST or here the error, right? I want to over here to print the parts. I want to print the parts here. Print group. We will print. Right. Yeah, over here. I will instead say, so this is my error and I have parts. Part can be printed. Print part is this function. This is a list of parts. Right? So can I just say over here? Can I say over here? List print parts. Right. This will tell me now. Yeah, so see, it says keyword. Yeah, so I have parsed the error AST node, and the error AST nodes contains the keyword, which is opening bracket, and then the hello world, right? This is the parts that have been parsed, and then since an opening bracket and a value together don't make the full syntax, that resulted in the error node, right? Now the question is, why did it not try to use the closing bracket? Because it says over here it's unexpected. When it says unexpected, right? It says unexpected, and then I actually finished parsed one as the error, right? Which means that I was not following with the closing bracket. Why I was not following the closing bracket? Because it's part of the continuation keywords. All right. Like there's an if somewhere that I need to have. I feel like continuation keywords should only be used at the beginning, but not in the middle. Something like that. We try to follow with a token as a keyword, right? But on the first iteration, we need to check that start value satisfy the previous filter. Continue with, yeah, this, something. Okay. Like if the continuation keywords contain the keyword, then we say none. That's why I'm not trying to do that, right? Let's try. So if I just comment this 2 lines, what's going to happen? Then it actually has parsed this thing successfully. Right? Yes. So I feel like continuation keywords should only matter if I have if I have not yet used a keyword. Used keyword, and so not used keyword, and this. Okay. Used keyword boolean. Used keyword parse 1. Over here I say used keyword is false. Oh wait, no, it's not here. That should be part of the parse. Yeah, so parse 1 should not have that as an argument. It's in a different place. Keyword, it's not here. It's part of the Go. We have the node. Used keyword. Boolean. Like that. There you go. So I go next. So this over here, I am following with the keyword. So used keyword is true, right? Because I have used the keyword. And in this case, I followed with a value. So used keyword is same as it was before. And then when I do when I'm skipping, it is the same as before. And then when I just start parsing one, obviously I have not used the keyword yet. Okay, maybe this. Okay, looks like this worked. Maybe. So this has been parsed. Let's try. If I have a plus plus here, so now this says skipping unexpected plus plus, right? So this was unexpected, but we still parsed successfully, even though we have an error. All right. Okay. If I say plus, what about this then, right? This is also skipping unexpected plus. Although, if I say hello world plus, what is then going to happen? It's going to say that we have the error node because hello world plus is unfinished node now, right? So it successfully parsed this as a partial addition, but it could not finish it. So we have an error. That makes sense, right? Okay. All right. Can I what happens if I highlight? It still has the plus. Wait, what? Why is the plus still there though? What did I do? What did I do in the highlighting? If we have an error, then I just print the parts, because I just print the token. Oh, I mean, it is a keyword. Yes, I have parsed it as a keyword. It's just like unfinished. Actually, this is highlighted correctly, because plus is a keyword. It's just unfinished, right? Which is totally valid. But if I say something like highlight something that actually doesn't parse, like a plus plus, then we crash. Beautiful. So I have skipped the unexpected plus plus. And then I would say that the closing bracket is actually unexpected. Beautiful. Now it's unexpected again. The plus plus works in the beginning, but not in the end. This is unexpected. Let's bring back the logs. I opened the bracket twice. I did this. I started to parse one. I skipped unexpected plus plus. Finished with no progress. Unexpected. You know what? When I say unexpected, I want to print the parts that I have parsed so far, because it is not obvious there from the logs. So unexpected over here, right? This is where I try to terminate. So I did make progress, and the node is not terminal, and I don't have a single value, right? Yeah, like log error. Parsed list print. I mean, we have these parts, right? List print parts part print like this. So parsed is an empty list. That's wrong. Obviously that is not a terminal node. But how did I make progress? Oh, I made progress because I skipped the error. Okay. If I skipped the error, then it should actually say no progress. I feel like the progress. So yeah, the progress. Made progress. Made progress is if the Lexer was not moved at all, right? But that's actually not the correct thing anymore. I should just say that made progress is like, since I'm storing the parsed progress over here, I feel like it's if the parsed. Oh, but it has the start there, right? Oh, and there could be comments too. There could be comments too, right? Count comments before. Let parsed len at start is parse_trav into list length. Made progress is parse_trav length is not equal to parsed length at the start. That's correct. Expected end of file got an opening bracket. Now I don't even go to the opening bracket. Made it even worse. Because that's not correct. Or is it? Wait, one. Well, no. Parsed. This is the parse. It's supposed to have like the keywords and stuff, right? Yeah. I am continuing with a keyword. I'm doing this. Over here, I'm doing that. Mm -hmm. I'm not going to get to the compilation and evaluation parts today. Just parsing. I'm not even sure that I can do the parsing. It seems fault tolerant. This code is not understandable anymore. This code is bad. So made progress was is just if I have, it's through the rewrite time. I don't know how to rewrite it to be like better though. That's the problem, right? This is the parser. This is literally the. I feel like this is the hardest part of the language, the parser, because it's extensible and stuff. Wait, start the parse one, finish the parse one, no progress? What do you mean no progress? That doesn't even make any sense here. This over here doesn't make any sense at all, this log. Because it should have. Oh wait, I'm trying to parse the simple one and I'm trying to extend it immediately, which is wrong. Right? Because if I have parsed the simple one here, I should exit, saying that I made progress. Because over here, I made progress. Yeah, I made progress and I should return made progress start, right? Wait a second. So I actually, yeah, because made progress no longer returns true, I guess. Because this parse simple, was not added to the parts. The parsed parts. Wait, when is it being added? Is it never being added? Hold on. Parsed start. The option to list. Yes, because parsed a simple. Should have made progress. Okay, that makes sense. Kind of. What happened there? Yeah, we should rewrite this from scratch. You're right, Nigel. But how? How to rewrite this properly? Maybe I should actually read about the things a little bit. Three-seater. Implementation. Parser generator incremental parsing library. It can build a concrete syntax tree for a source code and visually update it when the source file is edited. General. Fast. Robust. Dependency-free. Language bindings. Parsers. Underlying research. Practical algorithms for incremental software development environments. Context-aware scanning of parsing extensible languages. What is this? A PDF file. Let's see. Parsing extensible languages. This paper introduces new parsing and context-aware scanning algorithms in which the scanner uses contextual information to disambiguate lexical syntax. The parser uses a slightly modified LR-style algorithm that parses to the scanner the set of valid symbols that the scanner may return at that point in parsing. The set is those terminals whose entries in the parse table for the current parse state are shift, reduce, or accept, but not error. The scanner then only returns tokens of this set. An analysis is given that can statically verify that the scanner will never return more than one token for a single input. Context-aware scanning for parsing extensible languages. Extensible language specification. Lexical precedence relation. Modified LR parsing. CST. I don't know if I need that. Flexible and efficient, flexible incremental parsing. Error detection and recovery in LR parser. Error recovery. Is my internet bad today? What is this? Wait, what? How old is this book? How old is this? What's the date? AD. AD. Older than old. Approved for public release. Distribution unlimited. August 26, 19. What's this number? 1977? (1977) report date. A practical algorithm is described that allows an LR parser to parse past the point at which the error was detected. What is this table? Action table. Using panic modes. Is this also like a screenshot from a book that is like 100 years old? Looks like it. Not that old, 10 years older than me. Yeah. I feel like I'm stuck and I should stop doing what I'm doing, right? I should come up with a plan of how to do this correctly. But right now the problem is that how do I determine if this has made progress or not? Because I should return whether I have made a progress or I have not made a progress. And if I have been skipping the error tokens, then it means that I potentially not make progress. But skipping was before counting towards making progress because it was based on the Lexer position. So if I skip a token, it means that I have made progress. Over here, right? So like what's trying to even happen there, right? What is even trying to happen there? So what's trying to happen in this example is that we parse the hello world, right? And after the hello world, we can continue hello world with another value. Because technically Technically, A and B is valid syntax because we have syntax for function application, which just takes two values, A and B, followed by each other like this. So it's trying to read the new thing here. It's trying to read the new thing. It sees the plus plus, right? Plus plus is obviously not a valid thing. So it is trying to skip it. It's skipping it. And because it made progress, Matclad also had a good post about making a resilient LL parser. Matclad. I remember Matclad's is the resilient parser. This one, yeah, Matclad. The pret parsing on the Matclad was really easy to understand. So maybe this one will also be. In this tutorial, I'll explain the particular approach to parsing, which gracefully handles syntax errors and is thus suitable for language servers. Why resilience is needed because of this here, right? General, okay. Here, a user is the process of defining the FibRec helper function for a language server. It's important that the incompleteness doesn't get in the way. In particular, the following function fib should be parsed without any errors, such that syntax and semantics highlighting are not disturbed, and all calls to the fib everywhere type check correctly. This function itself should be recognized as a partially complete function, but various language server assists can handle completed correctly. I mean, technically I can, right? But like sometimes there is ambiguity. Like when I have partially written something, this is potentially partially written, not necessarily a function definition, but something else, right? So yeah, but sometimes we know that the beginning that has been written is mapped to a single thing. Sure. In particular, a smart language server can actually infer the expected type of FibRec from a call we already have and suggest completing the whole prototype. Rust Analyzer doesn't do that today, but one day it should. Yeah, that makes sense. Generalizing this example, what we want from our parser is to recognize as much of the syntactic structure as feasible. It should be able to localize errors. A mistake in a function generally should not interfere with parsing unrelated functions. As the code is read and written left to right, the parser should also recognize valid partial prefixes of various syntactic constructs. Academic literature suggests another lens to use when looking at this problem, error recovery. So rather than just recognizing incomplete constructs, the parser can attempt to guess the minimal edit which completes the construct and gets rid of the syntax error. From this angle, the above example would rather look like this. Right, where the stuff in a comment is automatically inserted by the parser. Right. Wait, actually, hold on. Yeah, we have... yeah. We can have the feature in the language server which auto-completes the definition, which is not like full, right? I start typing if, and it's like, does if underscore, for example, then underscore, else underscore. And then you just need to fill the underscores, right? Kind of similar to like snippets like this then. Resilience is more fruitful framing to use for a language server. Incomplete code is the ground truth, and only the user knows how to correctly complete it. I don't know. So they are saying that we should not try to do the error recovery, only the resilience. The language server can only offer guesses and suggestions, and they are more precise if they employ... I mean, yeah, sure. Right. Error recovery might work better with omitting understandable syntax errors, but in a language server, the importance of clear error messages for syntax error is relatively lower, as highlighting such errors right in the editor synchronously with typing usually provides tighter, more useful tacit feedback approaches. The classic approach is to explicitly encode error productions and synchronization tokens into the language grammar. This approach isn't a natural fit for resilience framing. You don't want to anticipate every possible error as there are just too many possibilities. Rather, you want to recover as much of valid syntax tree as possible and more or less ignore arbitrary invalid parts. Treesitter does something more interesting. It's a GLR parser, meaning that it non-deterministically tries many possible LR parses and looks for the best one. This allows Treesitter to recognize many complete valid small fragments of the tree, but it might have trouble assembling them into complete larger fragments. So we don't want to do the GLR, right? Top-down LL parsing paradigm makes it harder to recognize valid small fragments, but naturally allows for incomplete large nodes. Wait, which kind of parser do I have? I have no idea. Because code is written top-down and left to right, LL seems to have an advantage for typical patterns of incomplete code. Moreover, there isn't really anything special you need to do to make LL parsing resilient. You sort of just need to not crash on the first error, and everything else more or less just works. Do I have the LL? Maybe. For the lack of imagination on my side, the toy language will be parsing called L. It's a subset of Rust. There's the Fibonacci. Okay, we have this on grammar. Sure. This meta syntax is similar to BNF, but the notation is better specified and more familiar. Describe syntax trees rather than strings. Single quotes. Yeah, I'm not sure what is an NL parser. I have not read much on writing parsers. I just wrote one. Single quotes signify terminals. Sure. The grammar doesn't nail the syntax precisely. For example, the rule for parameter is name type underscore question mark says that param syntax node has an optional comma, but there is nothing in the above and grammar specifying whether trailing commas are allowed. A program is a single series of function declarations. Each function has a body. Designing the tree. Lexer. Okay, this is long. Hold on. Parser. With homogeneous syntax trees, the task of parsing admits an elegant formalization. We want to insert an extra parenthesis into a stream of tokens. The task of parsing admits an elegant formalization. We want to insert extra parentheses into a stream of tokens. At the beginning of the function and the end of the function. At the beginning of the parameter and the end of the parameter. Right? Note how the sequence of tokens with extra parentheses is still a flat sequence. The parsing will be two-phase. In the first phase, the parser emits a flat list of events. An event is either an open, close, or advance. In the second phase, the list is converted to a tree. Wait, is this is, I think this is literally what I'm doing, right? I'm not sure. I think this is literally what I'm doing. But I'm not sure. They say just advance here. Why don't they store any additional information here? Because it's based on the tree kind. You already know what to advance with, right? Because you know the tree kind. So the parser can open, close. Wait, close. Events at M index is event open kind. Open gives me the mark opened, which gives the index to this. Oh, so we open, okay, we open and we start by this being an error. But when we close it, it is now no longer an error. All right. So when I have successfully parsed it, we stop being an error node. Okay. When do I skip the tokens though? Do they ever skip the tokens? How do they do that? There's a set of short, convenient methods to navigate through the sequence of tokens, and is the look ahead method. Fuel. Sure. The function to transform a flat list of events into a tree is built involved. It juggles three things: the iterator of event, the iterator of tokens, and a stack of partially constructed nodes. Yes. Yes, so like that's how my parser works, right? We don't really have like events though. Yeah, so what is this used for? Like if they want to search, I mean, sure. When writing parsers by hand, it's very easy to accidentally write the code that recurses forever, whatever. We're finally getting into the actual topic of resilient parser. Now we will write a full grammar for L as a sequence of functions. Usually both atomic parser operations like function advance and grammar productions are implemented as method on the parser struct. I prefer to separate the two and to use free functions from the latter category. Okay. Let's start by parsing the top level. We want to start the function. While not end the file, if we are at the function keyword, then we want to parse the function p. P is the parser. Okay. Otherwise, we advance with error, expected a function. Okay. That makes sense. But I cannot do that. I cannot do that. Everything is an expression for me. Wrap the whole thing into the file node. Sure. What's the function? We are asserting that I am at the function keyword. Then I open. Then we close. That this is a function. Okay. I mean, this is doing what I am doing. This is doing exactly what I'm doing. Actually, this is my code. This is my code. Yes. So I guess I do have a LL parser or whatever. I just don't have the standalone functions like that because yeah. So like this is how I define the. This is although how we define the syntax, right? We have the keyword function, then we have the name, which is supposed to be an identifier, but I actually allow any. I mean, that's not how I define a function, I guess, but I can only allow like any expression inside here, basically, and then parameter list is any expression, and then we have an optional arrow followed by another any expression and stuff. Yeah, this is similar. So that yeah, and that's why they have these two phases, right? They have the list of events, and that's what I am calling the parsed. So the parsed is basically I have parsed partially like the thing, which is like the list of events, right? A key like at the open like something something. And then close. And when we close, this is when we already know what we have parsed successfully. It's just like if they had another syntax that starts with fn, but returns not a function but something else, they would have an if and they would close it with a different like kind, I guess. So expect function keyword, expect a name. Yeah, and then when you say that we expect the function keyword. Okay, so now I need to like look what they say when they have function expect, right? Self each the kind, return, and then error reporting. This one easier to do, right? So what if the function keyword is followed not by a name thing, right? What do we do then? And this is just a to do for now. Okay. Sure. So yeah, that's what we had before. We were just panicking. Okay. Yeah. Yeah. Okay, next. Albarsen function, yeah, sure. This is understandable. Now the list of parameters. That's understandable. Parsing types is trivial. The production is deliberately name type expression rather than type to avoid confusion down the line. Consider this. This is an expression which evaluates to a value. The same thing happens with types. For example, foo_int is not a type yet. It's an expression which evaluates its compile time to a type. Yes, sure. Block. Okay. Sure. Where's the error resilience? Where's the important stuff? Next expression would be to the expression call. This requires some preparation. Consider this example. Function 1 and 2. We want the following parenthesis structure here. Expression call, and then this ended. Expression call, like this. Expression name, argument list, sure. The problem is when parsing is at f, it doesn't yet know how many open events it should emit. Right. We solve this problem by adding an API to go back and inject a new open event. Okay. That's weird, but sure. I'm doing it differently. With the new API. Like, I instead do something different. Where's the error resilience? I was doing it like the pret parsing stuff instead. Here. Basic resilience. Okay, there you go. This is the start of the actually important stuff. Let's see how resilient our basic parser is. Let's check our example. Oh, wait. No, wait, hold on, what? Error expected are right parentheses. Oh, wait. No. When they say that they expect, they just log it, right? They just log it and they don't actually, they don't actually skip anything. All right. Right. So, like, it works for this simple example, obviously. Yeah, it works obviously for this simple example because none of the tokens need to be skipped, right? But yeah, we get this great result without much explicit effort to make parsing resilient. It's a natural outcome of just not failing at the presence of errors. Yeah, this already works for me. That's fine. Okay, homogeneous syntax tree supports arbitrary malformed code. Any syntactic construct parsed left to right, and valid prefixes is always recognized. Yes. If something goes wrong inside the loop, our choices are, yes, skip a token and continue with the next iteration of the current loop, break out of the inner loop, and let the outer loop handle recovery. The topmost loop must use the skip a token solution because it needs to consume all of the input tokens. Right. Right now, each loop either always skip or always breaks. This is not optimal. Consider this example. Function this, right? So we have this comma. This comma must be skipped, right? Here for f1, we want to break out of the param list loop, and our code does just that, yes. For f2, though, the error is a duplicated comma. The user will add a new parameter between x and y and z shortly. So we want to skip here. We don't, and as a result, the syntax tree for f2 is a train wreck. So f2 is just opening x and then a bunch of errors. Right. Right. So we want to skip this. For parameters, it is reasonable to skip tokens until we see something which implies the end of parameter list. So is it like, actually, it should be like dependent on what am I parsing? If I'm parsing the parameters, then I should skip. If not, then I should not. So should the code for error handling be defined for every like syntax node, kind of? Should we be skipping or should we not be skipping? What is a reasonable recovery in a certain general case? I don't know the answer, but follow sets form from follow sets from formal grammar theory. Give a good intuition. We don't want to exactly the follow set for param list. This is in follow, and we do not want it to be the part of the recovery set, but function is not in follow, and yet it is important to recover on it. Fn is included because it's in the follow for fn, and param list is the child of fn. So this over here, I call these continuation keywords, basically, right? Because I am currently parsing the fn. I'm currently parsing a function, right? So a function is partially parsed. We know that we can follow it or continue with certain keywords, right? Like an opening curly bracket, but not with another function, right? So that's literally what I was just writing. Okay, I feel like if I just think about it more myself, I can come up with an algorithm. I don't need to read this. I just need my code to be like a little bit refactored. I'm literally doing the same thing that I'm reading here. To require expression to consume at least one token, because it's not immediately obvious which tokens start an expression. Consume at least one token. This is my made progress thing. It's not immediately obvious, but easy to compute. Let's exactly first set from formal grammars. The first set from formal grammars. It's like, yeah. That's should skip token because of error, right? So it's literally this: the rule set or root next keywords. This is the first set from the formal grammars. Yeah, so basically, when I'm parsing a block, if we can start parsing an expression, then we parse an expression. Otherwise, should I recover? Yeah, if I have the function keyword, then we break. Okay. Yes. That makes sense. Advanced with so advanced is skipping the token, right? In the parser. Advanced with error is skipping the token and says that we expect the statement, but there was this thing. Probably, right? Function advance with error. Open, advance, and close. Error tree. Yeah, just like an error tree. So it gives me another error part. Sure. And then this is the end. I am doing literally the same thing. Okay, I just need this to be not buggy, right? I just have the bug. I was already doing the same thing, I think. I mean, I didn't read it fully, but I think I'm literally doing the same thing. So once again, the problem here is that okay. Yeah. Uh-huh. Yeah. I feel like we should just have the I feel like made progress here is just incorrect. Is made progress being used anywhere else? It's used here. It's used in continue with. Because on the first iteration we need to check something. How about made progress? How about this? Let made progress is a reference to false. How about this? We just say made progress, and then I will assign it to true whenever I actually make progress. And when did I make progress? When I say parse simple. Return. Parse syntax extension. Yeah. Let return is function value into return value. No. Say let result be this. Result. Nope. Let's do it the other way. Let's say that over here we have a function let result Let's simple the parse simple and simple. But then I will say some no. Wait, what? Is this how you format the code? Parse simple unit. Okay, so match simple with some, then so if it is some, then I'm going to say that made progress is true. Okay, sure. And then I also made progress when I have followed either with a keyword or with a value. So over here, made progress is true. And over here, when I followed with a keyword or with a value. Okay, this is going to work. Okay. Maybe this is all that I need. Hold on. Parse. Look at this, right? Wait, what do we have here? No, that's actually wrong. A little bit. I have parsed the entire thing. We print, this is my argument, which is a scoped. No, the argument is already an yeah, an error. And then we have a scope inside. Oh wait, what? We have, oh wait, what? I have an error, which is this keyword, because this keyword was not finished. Okay. This is almost correct though. So I have an argument which is this, but then I have the inner parsed expression which is scoped hello world. This one. But why is it like that? Why did it parse this thing, consuming both brackets? It's consuming now too many brackets. Let's see what happened. Okay, so first of all, we expected... This is already wrong. Yeah, so I have parsed the hello world here. Then I skipped the unexpected plus plus. Wait, and then it says skipping the unexpected plus plus again? So it skipped the second one on accident. It skipped the second one on accident. Whoops. Because when it says that I should skip this, yeah, because there was a plus plus that was that, so I returned none. So this token should be re-evaluated. I should calculate again what because my Lexer has moved because I have skipped the things inside, right? And then it parses it correctly. Okay. I feel like I'm not going to be very confident in this code at all. I need to actually rewrite this. So this has parsed successfully. Let's run the tests. Tests don't work. Keeping unexpected a comma. At 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Okay, so I have parsed this, but then we cannot parse the comma. Because comma is not at the root. Because but it is expected actually. That's the problem. That's the problem. It actually is expected. Because the unexpected ones are the ones that can like only that is only like at the root, right? But if there is a value, then it shouldn't. And rule set root next edge rule set edge map find edge, which is a value, into node next keywords. String set contains raw. Not. Okay. And then we pass the tests again. Okay. Nice. But I feel like this is all still wrong. This is I just made a bunch of hacks. That's what it feels like. Restart cast language server. Why are you not doing anything? Output cast language server. Right? Like this has been parsed, right? This has been parsed. But I don't see the highlighting of anything, which is weird, because it should be there. Cast highlight. Yeah. Can disable the logs. Okay. Yeah, like we have the parse error. Obviously, so we have the error, but I still can highlight this. Actually, also, this error token is not there. It's not shown in the syntax because I don't store the error token anywhere. So the highlight doesn't even print it, but it probably should. If I try to evaluate this file now, that doesn't even parse, then could not find print. Yeah, I mean, that makes sense. stdio print. There we go. So, like, we can actually evaluate this code, which has errors inside. We don't care about the errors, we ignore them. Why does the... like, if this is parsed and not even having the errors, why does the language server Yes, let's try to reload the window here. Maybe that will help for some reason. No, it will not. Do I have the doesn't parse thing? Oh, wait, it's because I am actually... Okay. I understand why. It's because in the... or maybe not. Cast language server. Parser error. Right, so over here I'm handling the parser error by just continuing. And I don't care about this. But in the language server, if we have the parser error, then we return the error, right? Yes. There you go. So I actually want this over here to be also continued. And we want to store this as diagnostics. So I'm not going to return some error and none. I will instead say effect continue, k with nothing, right? But we should store this as diagnostics and show this in the editor. Right? Wait, why did I reload? Restart. Come on, I know that you want this to be there. Parser error. Just continue. Yes. Let me see. Log. Percent a parser error. Okay. I will print it in the logs of the language server. Right. Let's see. Over here. Yeah, we have parse error. Oh, the example also. Yeah. Oh, I think. Oh, it's because it's not in the roots. I'm stupid. It's not in the roots because I'm not parsing all of the cast files. I need to list it here for now. Examples doesn't parse. Yes. There you go. Okay, so there you go. And now I can like format this code too. Okay, so and it actually can format this code, and formatting this code is removing this error node too. Okay, sure. And I can like hover stuff. Okay, if I say plus, right? Trying to compile error node, right? So like this over here, yeah, I have not made the compiler error resilient yet because so this over here has created the error node in the AST. So it cannot be compiled, obviously, right? Because this is not fully written yet. Plus 2, right? There you go. And then the type checking failed because I cannot add this. Although it's weird that the this error is over here for some reason. It's supposed to highlight this thing. This doesn't type check, that's sure. Fine. What if I try to format? We cannot format. Okay, that's fine. That's fine that we cannot format the code with errors. Okay, and then And then let's store these diagnostics in the language server. And I process a file, stores diagnostics. So we want to store this as diagnostics, right? Yeah. Process file, file state. Diagnostics. Oh, yeah. Hold on. Diagnostics, global state. So I kind of have like this error already. Has the type, which has the span and the message, right? So like that's literally the diagnostics already. But it's not necessarily belonging to this file. It's not necessarily belonging to this file. I feel like process file. I just have diagnostics here. Or something. Diagnostics. It's just a function from span and message. I don't know. It's a function that consumes diagnostics. Speed types diagnostic t. Right? Unit. Okay. So I just and what is diagnostic, by the way? We have code description, data, message, range. I should look at the. Should I not? I have diagnostics over here. Diagnostic T list. We have range. Yeah, so we no longer have parser errors to get state, processing file state. File state does not have a reference to the global one. Okay, I mean, technically I can store the diagnostics in the file state, but like it's not really what I'm supposed to do. Because it is not about that file necessarily. I should store the diagnostics in the entire workspace, right? Let's do the simple stuff for now. Diagnostics is LSP types diagnostics T list, right? Like that. That diagnostics is a reference to an empty list. And then when I want to store it, I say diagnostics is diagnostics plus a new diagnostic. Which has the thing. Which has all of these things. Let's see. So range is error span. Severity is error. Code is none. Code description is none. Source is none. Message is make string. Parser error message. Like that. And that's it. And let's say that diagnostics is diagnostics that I was been calculating. To do might be from another. Yeah, when file was included, diagnostics empty list. So like in the included files, I will never get the diagnostics. Hey, Camel was showing me fake errors again. Okay. Let's see. Oh, and then the diagnostics should actually report those diagnostics, right? Diagnostic you get from the file state. I should add those all to the list of state diagnostics. Like that. Yeah, there we go. Unexpected semicolon over here. Right? Unexpected plus plus here. Just skipping unexpected plus plus. Yeah, whatever. That's good enough for me for now. Although probably I don't need the message to be like that. Hold on. Processing. Parser. No, I just have the message. I don't have the span. It's because it's part of the message, I guess. Yeah. Okay. Yeah, so it says that we have the unexpected plus plus. Sure. The error message. I'm not going to improve the error messages, really. I don't care. This is understandable for me for now. If I say plus, like this, so now I have two errors in this file, right? We can actually see. Can I see like the problems of this file only? So we have two errors in this file, right? We are trying to compile the error node, which we will work on some other time, right? Because this should compile, even though we have errors here. And then over here it says unexpected closing bracket, right? Because we did not finish the hello world plus something, right? We were supposed to add something here. Right. Okay. What about this example? Is this correct? Trying to compile error node. Keeping unexpected closing bracket. So why is the closing bracket here unexpected? Because this is a module. That makes sense. Because I made it be the any there, right? In the syntax definition. Old rules. It says any, but it should not because I don't know. Because that one is actually expected in this case. Or maybe That compiles now. All right. Doesn't parse, still doesn't. Have you found any tools on format to format Dune files? I think my Dune files are formatted, yes, automatically already. Dune file, like if I do something here, it formats already automatically. I have format on save. Hate how the dependency section is just kind of free form. Dependency section. Where? I'm pretty sure also, like if I say this and I say a save without formatting like this, and then I do like Dune FMT, it's going to format this. So like it's doing this in the from the CLI too, but I think the difference is that this is a Dune file which is literally just Dune, but there is also a Dune file which is a Dune project, and I think for the Dune project that's not the case. If I have these dependencies have a space here, like on a Control S, like my VS Code is doing that, but I think that the Dune FMT is not going to do that. So Dune FMT is ignoring the Dune project file and Dune workspace file, but my editor still be able to format those. Maybe you can do OCaml format specifically. OCaml format like Dune project. No, not really. I don't know. I don't know what exactly is being invoked when I format this in the VS Code. Okay, I feel like I should commit this and I should think about my life. And maybe I should think about refactoring the parser. Like it's all correct, I feel like, but it's the really not understandable source code right now, and there are bugs because of that. But I'm doing it all correctly, just like written in these articles. I'm pretty sure. Error resilient parser, maybe. All right. Good enough for now. I noticed. I noticed a new person writing a parser right now in Golang. Nice. So let's go here. Thank you guys for watching. See you next time. Bye.
I think that was like the latest thing I needed to